to summarize those two earlier readings, we have two particular outstanding words, complexity and emergence. Please note that if I ever create a quiz out of this video lecture, definitely I will include writing down these two keywords in its own definitions, okay? Complexity and emergence. So though if I can teach just two concepts throughout this week's video lecture, I want to teach the concept of complexity and concept of emergence. So Krugman said that economic system is going to be complex system, and it requires feedback interactions between the market participants. And this complex system will create a general equilibrium theory, which is being considered as a very static model, into that will be turned into a dynamic model, which is where feedback can be going back and forth between the participants. And this complexity of those feedbacks between the participants, this complexity will create what? Emergence. And this emergence will be our answer to the market equilibrium creation. Okay? A pattern where Adam Smith mentioned as an individual hand. Okay? And Epstein Axtell also mentioned what? Many crucially important social processes are complex, which means that requiring participants, feedback loop between the participants. Okay? So we need to look into the meaning of those two words, because the complexity stands out, and they are being emerged, and complexity and emergence should be discussed. So first, let's look into the concept of complexity. A complexity is being defined as a characterization of something with many interacting parts in intricate arrangement. Its arrangement is being preset with careful coordination, and they are interacting with each other with these many parts, and they are being characterized in that way. So it's not just a one single unified part, and it does have an arrangement. It does not being isolated. It is not being isolated, and its actual study, the study of these complex linkages, this intricate arrangement, is the main goal of the complex system theory. While having said that this is a very philosophical or like very abstract definitions, if we become more practical or more like down to earth concept, we were able to see some of those complexity concepts here. One is the computational complexity from computer science. And that is one complexity that we discussed in the data structures course, right? And actually there should be interacting processes to make things algorithm complex, order of n squared, order of n cubic, order of n log n. There should be some data items interacting with each other, for example, like comparison, to do sorting. So that complexity in that concept is an interaction between the data items and the processes. On the other hand, here where we put more emphasis on this simulation course is complex adaptive system from the system engineering concept. And here, complex adaptive system, in my department, industrial and systems engineering, we have to know the systems engineering part as well. And complex adaptive system is being defined like this. The number of parts in the system And number of relations between the parts is non-trivial. And the system has memory and also includes feedback. And this memory is being named like what? States as, right? Up to this point, we have been observing many of those formalisms, and now we are being familiar with the concept of states. And system has states. System has states, right? And what we are missing is the feedback loop. And also many of those subparts of the system. We are going to have subparts of the system and creating interaction loop, feedback loop to each other. That's the agent-based model. And those systems will have collectively a state, and also each of those number of parts will have, as a small subsystem, will have a state. And the system can adapt itself according to its history and feedback. So adaptive, and it's a transition and state, external event and state will create a transition. That transition is the adaptation, right? Yeah. So for example, in the depth formalism, delta what external transition was state and the event, and it will result in next time state. That's the adapted result of the system's memory. And also the relation between the system and its residing environment are not trivial and non-linear. And also the system is highly sensitive to initial conditions. So let's imagine our society, that our society would not have been in this shape, or I'm not saying that our current society is that bad. I'm saying we have been transitioned into this state over time because we had a certain initial state. Okay? And initial state will govern its trajectory over time. And over the transitions and transition, with some virtue of the transitions, we can forget the initial state and eventually lead to a better state or another state. Having said that, initial condition will highly sensitively govern some transitions. And for example, one example of this complex adaptive system is people and their relations in the society. So society is complex adaptive system. Our social system is a complex adaptive system. It's not simple, it's not trivial. It's a mixture of people, and we are not living alone. We are not island, right? And we are connected to each other. And relations make the society transition and move. That's I see, or social scientists or complexity theorists sees our society as not just being individual modeled, but rather their interactions and relations are being modeled. Okay, I just mentioned some and discussed some concepts of the complexity, and this is some heterogeneous, the timeline or the overtime developments of the concept of the complexity. It's coming from the Wikipedia. It's very nice picture, and I'm really grateful that people who contribute to the Wikipedia by organizing all these informations as a free resource. I really appreciate that. And also, let's look into this, okay? As you can see that complexity has been evolved over time. Some concept has contributed in terms of the artificial intelligence. What is the artificial intelligence? AlphaGo shock. The Go community and Go champion was broken by the AI in Korea in early 2010s. And that really rapidly changed the Korean society to accept the AI concept. And having said that, such kind of AI development was not a recent motivation. it was a tradition or it was a goal to pursue since 1940s or 50s. And what we are discussing here, the construction of the agent, is one key detailed objective of creating AI, so that that agent has an AI, its own intelligence, so that it can make decisions by itself and adapt to our society and being a one individual as our society, okay, or one social entities. And that AI concept has been developed to the agent-based models or all those AI fields development and so forth, like this. And also this complexity concept and the computational sciences has been adopted to the social science field and some human studies field and also some policy-making fields, and so that they can be advanced through that timeline. So this complexity has been studied in many of those areas, and early on 1940s, von Neumann and other people contributed a lot to this world, but now that complexity concept has been commonly accepted, and many of our virtual worlds, simulated worlds, are now being has some models of the agency in those simulation models.